Hello, and welcome to this webcast, Optimized Material Handling Efficiency and Infrastructure with Lithium Batteries and Fast Charging. My name is Roberto Michel. I'm Senior Editor for Modern Materials Handling magazine, and I'll be your host for this webcast being brought to you by Green Cubes Technology, a provider of lithium power solutions, including lithium batteries and chargers for lift truck fleets. Lift truck fleet uptime and reliability are mission critical to warehousing and manufacturing operations. Companies are after energy savings for their lift truck fleets, but at the same time, they must hit material handling throughput targets and keep their trucks busy moving materials. Lithium-ion battery technology has emerged as a way to meet these needs, supporting high uptime via opportunity charging while making it possible to operate with one battery per truck rather than rely on battery swaps and associated storage and swapping processes, which is common with many electric lift truck fleets running on lead-acid batteries. Lithium-ion technology poses a solution, but how do you implement lithium and opportunity charging successfully? And how might the battery or charger choices you make influence your TCO, your total cost of ownership for your fleet? In this session, we'll cover these concerns and discuss how IoT and multi-voltage technologies and multi-output chargers can help meet your cost and efficiency goals for your fleet. To get a full take on these issues, we're joined by Robin Schneider, PhD, Director of Marketing with Green Cubes Technology. Robin knows the ins and outs of different battery chemistries and charger technologies, and more importantly, how companies can successfully transition to more energy efficient motive power while having better insights into costs. Just a couple of notes though before I introduce Robin. We'll have time for a short Q&A, so please submit any questions that you might have using the feature for that on your webcast screen. We'll get to these questions later, and if we don't get to your question, we'll move it over to our presenter who will be able to respond to you via email. With that, welcome, Robin.
Thanks, Roberto.
Please take it away.
Okay, thanks. So in this webcast, you're going to learn how to implement opportunity and fast charging using the latest improvements in lithium-ion products, such as fast charging batteries, high-power multi-output chargers, and the Internet of Things capabilities. Opportunity and fast charging is a practice applicable to all equipment in material handling, from small pallet jacks to larger forklifts and reach trucks. It'll help you meet your throughput and safety goals. So after a brief introduction to our company, I'm going to discuss some market research on the industry, and then I'll discuss charger technology, and then finally we'll go through some specific battery side improvements that are now available from our technology roadmap. Green Cubes designs and manufactures rechargeable lithium-ion battery solutions that are safe and accessible to the user. Our solutions ease the migration away from lead-acid, internal combustion engines, and other older technologies. Our vision is to design platforms that help accelerate the adoption of clean energy mediums. For nearly 40 years, Green Cubes technology has helped OEMs safely convert from lead-acid systems to the right lithium technologies for their operations. Among the many providers of lithium solutions, we stand apart for our precision-engineered conversions of material handling equipment, hospital systems, and telecom infrastructure. Our reputation and years in the business stand behind us to keep us innovating and driving ahead. We currently have more than 300 employees worldwide and have designed well over 100 power systems in the last decade. In addition to our power systems innovation, we're focused on the utilization of remote monitoring, also known as IoT, to provide a solution not just across our system or an individual manufacturing or warehouse site, but across an entire organization. We have 3 different business groups, an industrial and medical power and automation group that uses standard platforms and custom designs, a network power, telecom backup, and power platform group, and then material handling and other motive industries, such as ground support equipment. In this segment, we have a wide variety of battery products, charging systems, and remote management capabilities. And these technologies, of course, will be the focus of today's presentation. We offer more than 200 battery models for material handling equipment, including the smaller Class 3 electric motor hand rider trucks, Class 2 narrow aisle trucks, and Class 1 electric motor rider trucks that are used indoors. We have a variety of communication protocols, charger models, sizes, and harnesses. And our batteries are compatible with level 1 or level 2 CAN integration for a variety of different truck OEMs and all of the major ones. Recent surveys from the material handling industry show that most enterprises are focused on improving efficiency, throughput, and workplace safety. Lithium-ion batteries paired with our high-frequency chargers enhance an organization's ability to opportunity or fast charge without battery maintenance, and this reduces their infrastructure costs and eliminates common workplace hazards and addresses all of those issues. This survey shows the interest of Peerless Publications readership in various topics. The first one, by a long shot, is safety. And this is a major issue with older power technology. Not far behind down this curve, you can see cost cycle time and throughput, and then finally, environmental and sustainability concerns, which are farther down the list, but also the fastest growing. And all of these issues are addressable with new power technology. Another part of this survey shows where investments are being made. IT infrastructure is growing, and that's related to our IoT systems that I'll be discussing later. And in traditional physical infrastructure, lift trucks and accessories have a majority spend. So people are really looking at improving their lift trucks in order to make their warehouses more efficient. Let's look at some ways in which batteries and chargers contribute to inefficiencies at a high level, and then we can keep those in mind when we're looking at potential improvements. So getting operators to plug in and properly water batteries is the first issue. There's also issues with long charge times and temperature stabilization times that are associated with lead acid batteries. And then connector and cable damage is really common with frequent use in battery changing. And then there's always an issue, especially as the battery starts to degrade over its life, of having enough capacity to make sure that the operators can finish their shifts or finish the work that's needed. And then finally, there's the overuse and underuse of various pieces of equipment that can lead to uneven wear and tear on the equipment and accessories, like the batteries and chargers and the equipment themselves, and these can be addressed with IoT. So let's take a quick look at the basic power options that are available. There are two fundamental ways to power equipment, with a fuel-based system or an energy storage or battery system. Roughly half of material handling equipment in use today uses propane or diesel-powered internal combustion engines. And although these engines have high maintenance costs and there are sustainability and pollution concerns, and you can't use them indoors, their overall market share is not expected to change substantially because the alternative for them, the green fuel cell, is in relative infancy. However, with new CARB legislation that's coming down the pike, we do expect that Class 4 and 5 trucks will actually also be converting to battery power, some of them to lead acid and some of them to lithium ion. But the real shift that's happening right now is the conversion of lead acid batteries to lithium batteries. And that's because lead acid is very problematic. While it has a low purchase price, it can only be used for a single shift if it's being used according to the manufacturer's instructions. It requires regular watering and maintenance. and monthly reporting for environmental issues, and workplace injuries are really common. So lithium-ion is safer and more environmentally friendly, and it's going to make more sense for most organizations, especially if they have very heavy use of their equipment. So reflecting my comments on the previous slide, here we can see the adoption rate of these technologies that's expected over time. You see a slight decline in lead acid because as I mentioned, some of the electrification of class 4 and 5 trucks will likely go to lead acid batteries. And then you can see that internal combustion engines will remain relatively flat, and you see a small growth in fuel cells as they become adopted. But the really rapid change is in the adoption of lithium-ion technologies. And on the graph on the right-hand side, you can see that this is expected for all 3 classes of indoor use lift trucks, with the fastest growth being in the smaller class 3, but then also class 1 and 2 having an exponential adoption. So now let's look at opportunity charging, because a lot of the benefit that you see in lithium-ion batteries comes from the way it's charged. So opportunity charging and fast charge and so-called fast charging is a key differentiator for lithium-ion, and it really enables 24/7 or nonstop operation of the material handling equipment. Typically, fast charging requires specialized infrastructure for high power utility connections. Often you would need 2 charging cables to accommodate the current with larger batteries, and it requires retraining the workforce. So opportunity charging is not a new concept in this market. But lithium batteries really provide an improvement and a better actualization of this concept, that an operator can just plug in the battery during a break or lunch, and that'll enable 24/7 operation without a battery swap. So lithium batteries can truly be charged in 1-hour timeframes, and they better tolerate a wide range of depth of discharge, so they don't need to be maintained within the kind of middle range of their charge. So a short break really can bring back 25% of the battery or more, and keep the battery in its ideal state of charge for a very long cycle life. Because lithium batteries are protected by their battery management system electronics that are internal to the battery, there's no degradation or risk of over or undercharging, no matter how the operator behaves. They're able to continuously plug in during any off period, and they don't have to worry about the state of charge. And this will help prevent unexpected shutdowns. So why is it that we're able to do this with a lithium-ion battery? So most of the advantage at the system level comes from the lithium-ion battery's charging properties. With both types of chemistries, there's a constant current phase and then a constant voltage or high state of charge phase, where so the battery is basically fast charged at a constant current and then topped off at a constant voltage. At first glance, these graphs look really, really similar. But what you'll notice is that the constant current phase for lead acid is a C/5 rate. And for lithium ion, it's a 1C rate. So the lithium ion battery can be charged 5 times faster. And then it can be charged almost all the way to full charge for that top off, until it goes to that top off period, where lead acid batteries, it's recommended to only go to 80%. And then you have to be in that top off phase for much longer, making the overall charge time something more like 8 hours. So let's look at the recommended charging method in a little bit more detail. So lead acid batteries are recommended that you discharge the batteries fully, charging at a C/5 rate, so that means a 5-hour charge time, resting for an 8-hour cool down period, equalizing the batteries on a weekly basis, and 1 full charge and discharge cycle per day. So really, you would require, if you had a 24/7 operation, you would require 3 batteries per truck. And if you did that, you would get 500 to 1,000 cycles from a flooded lead acid battery. If you were to try to opportunity charge a lead acid battery, which a lot of people do, you typically charge at a C/4 rate. So it's really not that much faster. But sometimes people will charge as fast as a C/2 rate. But if you do that, you generally get very, very poor cycle life, like 200 or 300 cycles, and you definitely would shorten or violate the manufacturer warranty. Lithium ion, on the other hand, regardless of the state of charge of the battery, will efficiently accept the power and increase its state of charge. It doesn't matter if you're in the lower part of the range or the top part of the range. It can immediately be discharged in use, so there's no cool down. It can be charged in a little bit over an hour or a 1C rate. And then we have some technology that can be charged even faster that I'll talk about later in the presentation. And even with this kind of very high use, you get 2,000 to 4,000 cycles before you get to 80% of the original capacity, which is typically how we would define end of life for a lithium-ion battery. And you get the full warranty even when you do this very aggressive opportunity charging. So what are some best practices for opportunity charging? First, to do a power study where the battery activity is monitored. And based on that data, you can determine whether there's adequate opportunities for charging throughout a shift. If there's not really any downtime for the equipment throughout the shift, then the batteries will need to be charged like for an hour before the single shift. For single shift versus multi-shift operations, that'll determine the value of an opportunity charging regimen. If the enterprise operates in a single shift, a fully charged lithium ion or a fully charged lead acid battery should power that vehicle through the shift. When the second or third shift is added, that's when opportunity charging is really advantageous. Because it can be used to recharge the battery in increments and ensure that it's powered throughout all of the shifts. Another thing is to look at the existing lead acid chargers to determine if they're compatible with lithium-ion batteries, which generally they are. And then assess the power output of the existing lead acid and lithium-ion charging infrastructure. If the power rating on the charger needs to be much higher when opportunity charging, then you can look at getting a new charger, which I'm going to discuss a little bit later in the presentation. And then finally, you can consider the multi-voltage battery that I'm going to talk about, which can enable even faster charging. Okay, so if you need to upgrade your charger in order to do opportunity charging, we do offer a multi-output charger that has a lot of really good features for opportunity charging. So the SafeFlex charger utilizes CAN communication to automatically start and stop charging based on the demand given by the SafeFlex lithium-ion batteries that we offer. This allows for smart and safe charging of the material handling equipment without the manual input of the operator to start and stop the charging. There's a single input line needed, and then you can charge up to 3 pieces of material handling equipment at the same time. So this reduces installation costs because you don't need to run multiple circuits or lines to accommodate the same performance, and you can have a single charger. There we offer a 15 kilowatt model and a 30 kilowatt model to right size the charger without having to invest in multiple chargers. And it covers a lot of different possible voltage mixes within the fleet. Having the ability to detect and charge voltages from 20 to 120 volts allows for great operational flexibility and commonality of operation and things like spare cables. The SafeFlex charger is a high frequency unit, allowing it to be built in a very small package for its power output. So this allows you to mount it in multiple fashions, saving on valuable real estate within the warehouse. The efficiency of this charger is up to about 97%, which will lower the cost of energy consumption that you need to power the material handling equipment. So the SafeFlex charger can replace a large amount of energy used during a shift if you used it for fast opportunity charging during shifts, break changes, and lunches. As I mentioned, it's small and lightweight. That allows for lots of different configurations. You can wall mount it, you can mount two against a single stand. We have the same size for both the 15 and 30 kilowatt units. And like I said, there are up to 3 outputs with 5 different configurations. So you can charge 3 batteries at the same time or 2 batteries from a single charger. We also have plans with the charger to introduce an IP55 model for use outside the warehouse. So what are your considerations when looking at a charger? So the state of the art for material handling chargers is to do high frequency and modular electronics, to have a really compact footprint, enabling wall and elevated installations, like even putting it way up into the rafters, having multiple charging ports, supporting different truck voltages for concurrent charging of dissimilar trucks. Auto detecting via CAN bus for things like voltage, current, and the different cutoffs. And then having it wired for communication via the Internet of Things. And then also being able to charge different types of batteries. Greater than 95% efficiency would be considered state of the art. And then a wide range of safety approvals. So now I'm going to talk about how you can really take advantage of some of these technologies and fast charging with what we call our multi-voltage SafeFlex battery. So this is a very advanced version of lithium-ion technology that's available only through Green Cubes. So the lithium SafeFlex battery systems are high cycle life, maintenance-free solutions for lithium for industrial vehicles. And they're fully customizable in terms of features to meet the most demanding requirements. The drop-in replacement batteries upgrade from lead acid to lithium in a very simple way. They're sized to fit the standard motor power lead acid battery, including things like weight requirements. The multi-voltage battery completes a full charge in less than an hour, and it's offered in 24 and 48 volt combinations, 36 72 volt combinations, and 48 96 volt combinations. It's common for use in high capacity batteries, such as a large 48 volt battery, and it can be charged with 2 cables to increase the charge current. The multi-voltage battery utilizes a single connector 4-aught cabling, which delivers cost efficiencies and minimizes the chance of cable damage over traditional fast charging with dual cables. Other than the battery configuration itself, the multi-voltage battery uses standard chargers and requires no changes on the equipment. So let's look at how this works in a little bit more detail. So basically, the battery would charge at 96 volts and discharge at 48 volts. And a a 30 kilowatt hour, 48 volt, 600 amp hour battery, which is a large, but sort of common size, could be fully charged in less than an hour at 320 amps with one standard Anderson connector. So you can charge a class 1 248521 battery in 1 hour with a single connection. And you can see this graphically on the right showing different charge times, lead acid versus standard lithium versus the multi-voltage battery, and the time and the amount of kilowatt hours that you would achieve. Now let's look at remote management of the fleet using the Internet of Things. This is for asset utilization, service, and support. So the Internet of Things allows for remote monitoring of batteries via Wi-Fi, which can be shared with operators and other stakeholders, including people who are remote to the site. This can be used to right-size the batteries for optimization of CapEx expenditures, and real-time fleet management can reduce OpEx expenditures by looking at how those batteries are being used and making sure that they're being used in the most optimal and efficient way. It's a pretty simple concept. Essentially, there's a wireless gateway which connects to the internet to provide the data. The battery management system is already collecting very detailed real-time information about the battery usage and about the health of the battery and looking for maintenance issues. And it's just a question of capturing that and reporting it back out in a way that's something that the user can utilize. This information can be collected on a local laptop or monitored off-site by employees who want to look at overall company asset utilization. So here you can see the data output from our IoT system across multiple sites and what it would look like in real time. We have an example of a customer who looked at asset utilization during trials and noticed that the batteries were underused at the initial location and then relocated them to a second site when it was ready to get updated power technology. And this saved them significant cost. You can also see that the system is being used for ongoing maintenance. Now let's look at the improved safety and environmental benefits of lithium-ion. We're going to need to contrast the advantages of lithium-ion with the challenges of using and maintaining lead-acid batteries. Charging lead-acid batteries is hazardous, but we think of it as, or many workers think of it as, a kind of routine activity. So they may not think of it that way, but there are risks from hydrogen gas formation when the battery is being charged. There's risk of exposure to sulfuric acid from any spills and leaks. And there's also really common physical injuries from the battery's weight. Repetitive use injuries like sprains and strains are really common. And then the highly corrosive electrolytes in the batteries can cause respiratory irritation, eye damage, skin irritation, and it can even erode people's tooth enamel over time. And then the sheer size of the material handling batteries means that crush injuries also can happen during battery changes. The fluid level is extremely important, and maintaining it at a safe level requires regular watering. Overwatering and underwatering can both damage the batteries. Conventional batteries contain a liquid electrolyte, which is a mixture of sulfuric acid and water. And when the batteries are being charged, they generate hydrogen gas that's explosive in certain concentrations. So you need a really advanced ventilation system for the maintenance of lead acid batteries to get enough fresh air to prevent any explosions. The electrical voltage created by the batteries can ignite the flammable materials and cause burns. Splashing of acid is also a risk. And so there needs to be an investment in personal protective equipment like splash goggles, face shield, gloves, eye wash stations, and emergency showers and all of those things are necessary, and they take up space in the warehouse. Lithium-ion batteries, on the other hand, are made up of cells that you can see in this picture on the right. The cells are sealed, and they have many safety factors designed into the cells and into the battery pack or the system. First of all, we use lithium iron phosphate cells, or LFP, which is the safest and longest cycle life due to its very stable chemical makeup. Within the cells, there's a component called a separator that is in between the anode and the cathode layers. And that's a fundamental safety feature. And it can be self-sealing, which means that if there is some kind of puncture of the battery, the separator will actually shut down and prevent any further shorting. The electronics of the battery provide protection against safety events with incorporated fuses, and they protect against overcharge, overdischarge, and high and low temperature charging, which prevent a dangerous situation for lithium-ion batteries. Lithium-ion batteries are, excuse me, maintenance-free over the lifetime of the truck. And this prevents the possibility of user error and greatly reduces the risks in the workplace because you're not doing any of those watering procedures. Now let's take a minute to look at the environmental advantages of lithium-ion. First, lithium-ion is a fairly broad bucket of battery types, but there are several different versions available for different applications. High capacity, low power, long runtime batteries that are based on a cobalt cathode are often used in consumer electronics. There's medium rate chemistries used for applications like e-bikes. And we've selected a special subset of lithium-ion called lithium iron phosphate because it's well matched for the material handling industry. We chose this type of lithium-ion cell chemistry because it's the highest power, shortest charge time, has the longest cycle life, making it well suited for something like an industrial truck. So for any lithium-ion, you would have a higher discharge and charge efficiency, and that would reduce energy usage, which lowers electrical costs. And then you have reduced water consumption because you're not having to water the batteries. There's no hazardous spill precautions and procedures. There's less material waste and scrapped due to the increased cycle life. There's higher energy density and reuse for other applications. LFP is non-toxic and doesn't contain any rare metals. Iron is a readily abundant ore, so it's less susceptible to supply chain issues that you may have heard of in the news about, like the supply of cobalt and things like that. LFP is UL, CE, and RoHS approved, and it's also easy to dispose of or recycle because it doesn't have any of those heavy metals. So now let's look at how you can reduce the total cost of ownership when you put all of these things together. And that's due to both the reduction in battery maintenance infrastructure and the increase in throughput. So I discussed the challenges associated with lead acid batteries, and that contributes to a high total cost of ownership with the lifetime of the battery usage. So it's low capacity, heavy and large. It needs a lot of maintenance, watering and cleaning acid residue. It requires monitoring over a charger interface, which takes like 3 to 5 minutes per battery because the battery itself is dumb, if you will, and doesn't have any electronics that can report usage. So it can only be monitored through the charger. There are environmental and recycling issues. You have to do government reporting. And again, there's workplace injuries, which can increase insurance costs. Then you have 8 to 16 hours of charging and cooling time. So for every 24-hour period, you get one 8-hour working shift and 2/3 of downtime for each battery. Lithium-ion has several benefits that lead to a lower total cost of ownership. So there's the long cycle life, which is useful for a product life of up to 10 years. It accepts partial charging without degrading the battery life. It eliminates battery changes and maintenance and associated workplace injury. There's a long runtime that can be tailored to utilization. There's faster charging times with opportunity charging. That means you don't need any dedicated charging time. The electronics required for safety and communication enable remote monitoring and troubleshooting. And in the end, there's even the potential to reduce the number of trucks required because you can do all of these right-sizing efforts. So how do we quantify these gains? First, there's the capital expenditure improvements that are brought by the features of these systems and optimized during design with the IoT interface. Everything from the batteries themselves to the charging rooms can be right-sized. You can eliminate battery handling rooms, ventilation accommodations, eye wash stations, and safety gear. You can reallocate those battery rooms to become an additional staging area or break room or anything. And then there's the operating cost improvements. So there's the increase in productivity, which lowers that cost of operation by about 30%. There's the low electrical costs for battery charging, which is about 20% because lithium-ion charging is 98% efficient versus 80% efficiency with lead-acid batteries. There's improved safety conditions for your employees. There's improved environmental conditions, and then improved asset utilization. And then finally, lower truck maintenance costs because of the very uniform power distribution associated with lithium-ion batteries. So here's an example of an ROI analysis or return on investment analysis that we did with one of our customers. This example is an 80 truck fleet that was located in the state of Florida. There are a few notable points that I want to bring to your attention. So you can notice that the CapEx expenditure between lead acid and lithium is roughly the same over a 5-year period. The main difference is that the lithium solution has a higher upfront cost and expenditure on the battery assets, while the lead acid solution has expenditure on the lead acid battery spread out over the 5-year period. Notice the annual maintenance costs for propane and lead acid are roughly the same at around $600K per year, while those maintenance costs are basically negligible for a lithium-ion solution. And then you can notice that the fuel cost for propane is substantially higher than lead acid and lithium batteries, but the lithium batteries require less electrical energy for charging than an equivalent lead acid solution. This is the lower consumption of power that's attributed to the higher efficiency of lithium-ion. So the net benefit is that our lithium-ion solution provides about a $2.8 million CapEx and OpEx savings over propane and a $4.2 million savings over lead acid solution. And for companies that have green initiatives underway, the propane and lead acid solutions generate an incremental 8 to 11 tons of carbon emissions over a 5-year period. So now I'm going to turn it over to Roberto at the end of the presentation and take some questions from the audience.
Thanks, Robin, for the presentation. We do have some questions which have come in. One, it's talking about a couple of different battery chemistries for lithium here. Are the maintenance requirements for NMC, I think that's the nickel manganese, the same as LFP batteries? Are the maintenance requirements?
Yeah, so All lithium-ion batteries are sealed, so there's never any maintenance or anything like that. So in the sense of doing like something like watering, NMC and lithium and LFP batteries would be the same. But NMC chemistry is really originally designed more for things like consumer electronics or smaller applications like an e-bike. In order to use it in larger material handling equipment, you kind of have to oversize the capacity of the battery in order to get the same cycle life you do with LFP. If you don't do that, then the cycle life is quite a bit lower for NMC. And then, so it would need to be replaced more often. So if you may not get the battery to survive the lifetime of the truck with NMC. And so there's maintenance in the sense that you may have to do battery replacements more often.
Okay, understood. Can you discuss the charger's applicability to a highly mixed fleet?
Yeah, so as I mentioned, it does automated voltage detection via the CAN bus communication, and then it can charge many different voltages. So if you have a mixed fleet, say you have some 24-volt pallet jacks and some larger 80-volt trucks, and it's some mix of those, you can charge all of them on the same charger. So it's really good in the sense that you don't have to have like a single charger and a single truck matched up.
Yeah. Okay. So the BMS is smart enough to tell the charger kind of how it wants to be charged for different batteries.
Exactly.
One person asks, I hear a lot about fuel cells. Why aren't they gaining market share faster?
So in my personal opinion, and this is just me looking into the future, I believe that fuel cells and lithium-ion batteries will exist in a sort of clean, green infrastructure in a similar way that lead-acid batteries and internal combustion engines have coexisted. And, we'll see them, each kind of occupying their own niche, where the advantage of, having a continuous fuel lends itself to fuel cells, and, in charging, with opportunity charging would lend itself to lithium-ion batteries. So I believe that they will coexist. The problem with fuel cells really is that the hydrogen infrastructure just isn't there yet. So I do know of several very, very high use facilities that have actually implemented fuel cells because they were, the operation was such high usage that it actually made sense for the end user to put in the hydrogen infrastructure. But that, typically doesn't exist. So you'd only see fuel cells adopted in like a really, really gigantic Amazon warehouse.
Mm-hmm. So, Robin, someone asks, when will the new chargers be available to the public? I'm assuming you have some new chargers that are coming out, and will they be sold through distributors?
Yeah, so the charger is available today. And we are selling it through our dealer network in the same way that in the same channel that we sell our batteries through. So we typically don't sell the batteries or chargers direct to end users, and we would direct end users to our dealer network.
I see. One more question. We have someone who asks, can you explain more about what is meant by truck integration?
Yeah, so that's a good question because people use the word integration and mean a lot of different things. So there are some truck OEMs that offer what is called an integrated truck, where the lithium-ion battery is actually integrated with the truck chassis as sort of a permanently embedded battery solution. And that has the advantage for the operator that the truck OEM can take advantage of the small size of the lithium-ion battery and use the additional room in the truck to improve the ergonomics for the driver. Then we have what is like more common, where the lithium-ion battery is used as a drop-in solution for a lead-acid battery in an existing truck design. So the lithium-ion battery has weights and everything to directly replace a lead-acid battery. But the battery then needs to somehow communicate to the operator what its charge status is, how much runtime is left, that sort of thing. And if the battery can't communicate with the truck, then you have to use an external BDI. But you can have so-called battery integration with the truck, where the battery communicates to the truck and can show its fuel gauge information through the normal truck user interface.
Okay. Well, I think we've run through the questions. I want to thank you for all the knowledge you've shared about battery choices and opportunity charging, Robin. And that does conclude this session. Thank you for attending.
Thank you.